Hi everyone, welcome to this lecture. So in this lecture, we will review our knowledge of a gradient descent. If you remember, we have already studied gradient descent in our prereq section, which is regression analysis. And we have also learned about the gradient descent in our back propagation section. So it is highly recommended not to skip any previous section before going to the forward. So in this lecture, we will learn more about the gradient descent. So what is gradient descent? It is a basic algorithm or it is a basic optimization method which is used to minimize the error with respect to the weights of a neural network. That is, we use gradient descent to update the weights of a neural network in order to reduce the error of a neural network. There is an important parameter in a gradient descent optimization algorithm, and this parameter is called learning rate. So the learning rate determines the step size of the update used to reach the local minima of the loss function. So basically, learning rate is the step size. We have to select whether the learning rate should be small or large when we have to apply a gradient descent. If we set a learning rate very large, so there is a chance that we skip the global minima and we move on to the other side of a loss function. Therefore, it is advisable to select the small value of a learning rate. So we will discuss this learning rate in this lecture. So how to apply a gradient descent? So basically from the definition of error, we know that error in a neural network is a difference between the actual value and the predicted value. If the actual value and the predicted value of the model, if they are same, then there is no error. If there is an error, we need to convert this error into a loss function. So the error which is converted into a loss function, that loss function is called mean squared error. So we have an error, then we square the error. You can see we have squared the error and then we take the mean of all the squared error. So it will become mean square error, which is the loss function. Now the next step is to apply the gradient descent to this loss function in order to reduce the loss function. So if you see here, I have replaced the predicted value with Wx plus W naught. This W is the weight of a neural network. This X is the feature matrix and this is the bias value. So this is now the equation of a mean square error on which we can safely apply the gradient descent. So gradient is basically a first order derivative. If I take the derivative of this equation with respect to weight, it will be the gradient. And if I take the derivative of this equation with respect to the bias, it will be the gradient with respect to bias. So I have to calculate the two gradients here. One will be used to update the value of the weight and another will be used to update the value of the bias. So if I take the first derivative of this equation with respect to W, which is the weight of a neural network, I will get this equation. And similarly, if I take the first derivative of this equation with respect to a bias, then I will get this equation. So this is the gradient with respect to W and this is the gradient with respect to bias. Now I will use these values to update the value of the weights and bias. Look at this. These are the equation of updation. Here I am updating the bias and here I am updating the weight. If you see, this is bias. This is the old value of the bias and this is the updated or a new value of a bias. So the new or updated value of bias depends upon the old value subtracted by the gradient multiply with the learning rate. The same equation will be used for weight where I will use the gradient of a weight. If you see, alpha here is called the learning rate and it is the important parameter of a gradient descent. It is also called the step size of the gradient descent. So we can see by calculating the gradient how we can update the value of the weights and bias. Now this is another explanation of a gradient descent. If you see here, we have a negative sign associated with this updation term, which has a gradient multiply with the learning rate. So why we have a negative sign? So negative sign indicating that we are moving in the opposite direction of the gradient. You see here, if the gradient or a slope is positive, so this is our loss function surface. You can see we have this surface. This surface is called a loss function surface, and we got this surface by plotting a loss function against the weight of a neural network. So this is our target. This is the target of a gradient descent where we have to reach where the loss is minimum. So if we are here, this side of the loss function has a positive slope. So if we are here, we have to move in the opposite direction of a positive slope. And if we are here, which is a negative slope, we have to move in the opposite direction of the negative slope. So we always move in the opposite direction of a slope, which is a gradient. That's why we have to put a negative sign with this equation. Now, what does positive slope mean? So the thing is, if we move along the positive slope, if you move in this direction, it means weight is increasing and loss is also increasing. So if you are at a positive slope, then you have to move towards left side, or you have to move against the positive slope in order to reduce the loss. So if we are at the positive slope, we have to reduce the weight in order to reduce the loss. On the other hand, if we are a negative slope, we have to move towards right. Moving towards right means we are increasing the value of weight, because if you see the weight axis, whenever you move towards this direction, towards right, weight increases, and when we move towards this direction, weight decreases. Therefore, if we are here and we have to reach here, we have to move towards right direction. It means if we are on a negative slope, then we have to increase the weight in order to reduce the loss function. And if we are on the positive slope, we have to reduce the weight in order to reduce the loss function. So this is the importance of understanding the concept of a positive slope. So it means if we are a positive slope, we will reduce the loss function by decreasing the weight. And if we are on a negative slope, we will reduce the loss function by increasing the weight. So I hope you understood the concept of a gradient descent, how it applies and how it use a step size or a learning rate in order to perform well. Thanks for listening this lecture, and I will see you in the next lecture.